Welcome back. Today we're going to continue Chapter 10, Sequences and Probability, and we're actually going to jump to Section 10.6, which we will spending 3 total lessons on, and this will be the last section we do this year. And the reason I'm ending with this is because it is my favorite type of math out there. You can see Section 10.6 is just called counting. This is actually, there's a whole branch of mathematics that's just looking at how to count things. And that might seem pretty simple, but as you will see in these 3 days, it can get pretty confusing. This type of mathematics is called combinatorics, and it was my favorite class that I ever took in college, was the combinatorics class. So, let's take a look at an example. Here's a menu at Simply Burgers. There's a meal deal in which you can get 1 burger, 1 drink, and 1 dessert for $6. So you pick one of these burgers, one of these drinks, and one of these desserts. Now, if it were me, I would get a cheeseburger, cherry coke, and a malt. So that's the meal I would order. Now, the question I usually ask in class is, could all of us in the room order a different meal? And then we've got to count how many people are there. Usually there's around 20 or so. Sometimes less, sometimes more. But the key here is to figure out how many meals are possible. And hopefully you've seen problems like this. But the general idea here is if there's 3 options for the type of burger and 3 options for the type of drink and 2 options for the type of dessert, you can just do 3 times 3 times 2, which in this case would be 18, depending on whether there's more or less than 18. That would tell us if all of us could order a different meal or not. Now, what if they add another option to the menu? What if they add another drink option? Now how many meals are possible? How did that change? So now there are 3 options for a burger, 3 options for a drink, and 2 options for the dessert. So you could just do 3 times 4 times 2, which is 24. So there would be 24 different meals combos available. Now this is called the fundamental counting principle, or just counting principle. So the counting principle, or fundamental counting principle, says the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So if there are something like A ways to make a first choice and then B ways to make a second choice, the number of total ways to make both choices is A times B. That's called the fundamental counting principle. And it seems pretty easy, but as you will notice, there are a lot of real-world problems that can be approached by simply applying this simple principle. But you can see it can get a little confusing. So let's take a look at the following. Suppose a set of license plates has any 3 letters followed by any 3 digits, and there are 10 digits because 0 is a possibility. And then it's also important to know that there are 26 letters in the alphabet, but I hope you already knew that. So how many different license plates are possible? So basically, you've got to choose one symbol to go first, another symbol to go second, another symbol to go third, and so on until you have all 6 symbols. So what I think about when I'm doing these problems is I just draw blanks for all the choices that need to be made. And I know I'm just going to multiply these 6 blanks together once I fill numbers in each of those blanks for how many options there are for each choice. So since there are 26 letters, the first thing we'll have 26 ways to choose, so you put a 26 there. Second thing is also 26 options. Third symbol is also 26 options. In terms of digits, since 0 is included, there are 10 options, followed by 10 options, followed by 10 options. So when I plug in those numbers, I get 26 times 26 times 26 times 10 times 10 times 10 for a total of 17,576,000 different license plates that could be made. But sometimes there are rules about what can and cannot happen. So let's say I'm going to make license plates now, but I'm not going to be allowed to repeat letters or numbers. So you can see like here, UU, that would not be allowed because I can't use the same letter twice. So I would start with my 26 or my 6 blanks again, and I'm going to multiply these 6 numbers together, but I have to think about, okay, in that first symbol, how many choices are there? Well, I can choose any letter for that first symbol, so I'm going to start with a 26. But if I cannot repeat a letter, there are no longer 26 letters possible for the second option because I've already used one of them in the first place. So now whatever letter I use is excluded for the second place, so now there are only 25 letters. Now for the third place, I've already used 2 different letters, which now further limits the number of letters available down to 24. And then in the fourth place, I choose a digit. I can choose any digit, 0 through 9. None of them have been used yet, so there are 10 possible digits. But then in the fifth place, I've used a digit, so I'm limited now to the 9 remaining digits. I don't know what digit was used, but I know I used one of them, and there are 9 left. And then by the time I get to the last symbol on this license plate, I've used 2 digits. Again, I don't know which 2 I've used, but I've used 2 of them, and I know there will be 8 remaining. So in this case, I get 26 times 25 times 24 times 10 times 9 times 8, which would give me 11,232,000. So you can imagine there are a lot of other types of limits that could be put on this. Like let's say I'm going to do a license plate that doesn't have the letter A first. Well, then there are, 25 ways for the first choice, but then I could have the letter A second, so then there'd be 26 for the third choice, and then 26, and then 10 times 10 times 10. So there's a lot of different iterations and ways to approach problems using the counting principle. All right. Let's take a look at another example here. Let's say there are 9 kindergarten students about to line up to go to recess. How many different ways could they line up? So here are my 9 students, and basically I think about this problem the same way I think about this problem. I'm just filling spots. Instead of spots on a license plate, I'm filling spots in line. So what I do is I draw my 9 blanks, and then in each one of those blanks I write down how many different ways that I could make a choice for that spot. So I'm going to start with this first spot. So how many different ways are there to fill that first spot? Well, there were 9 students, so there are 9 different ways that I could fill that first spot. So it's any one of those 9 people, so I would put a 9 there. But then once I fill that spot, so let's say this person is in the first spot in line, to fill the second spot, you can see that there are only 8 choices remaining. I can choose any one of these 8 remaining people. So let's say I put that person in the second spot, and now there are 7 possibilities left for the third spot, and then you can see there are 6 possibilities left for that spot, and so on each time I use somebody that limits the number of people remaining for the next spot. So basically this is going to be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And hopefully this rings a bell. Back in section 10.1 we learned that this is basically the definition of a factorial. So this ends up being 9 factorial. So 9 factorial is 362,880. And this is one of the reasons that factorials are my favorite operation, because they actually count things in the real world. They are used in counting. To count the number of ways to line up 9 people, you can just do 9 factorial. And that's why I think factorials are great. So there's a reminder of factorials that we went over in 10.1. But factorials can help you if you're lining everyone up in line. So that's it for today, just basically focusing on the fundamental counting principle. And in our next lesson, we're going to learn about some other counting principles. But for now, give that homework a try and let me know if you have any questions.